Hi everyone, my name is Bastian. Aiming, Pointing, Steering is a game design theoretical paper that I have written with Hendrik Knoche. This QR code takes you to our website where you can find all materials from this talk. Our work reviewed some fundamental building blocks that we call tasks, which turn out to be useful terminology to describe game interactions structurally. We all know games are powerful as vehicles to get people to behave in a certain way, yet games are complex to scientifically design, study and employ as solutions to our real-world problems. Because games are complex mediums, we also often let games' surface representations slip into our language, which obscures what underlying interactions we deal with. Just think of genre namings like racing games or first-person shooter, for example. Many games are studied, described and published without this abstraction level, and that makes it difficult for ourselves to synthesize our work. When we think of games, we popularly describe them from their representation. For example, we might describe this game as a game where a character has a goal of walking across the river. Underneath that representation, games have an underlying system which we can describe in abstract terms. Existing work within game ontology differentiates between representational language and structural language. For example, in abstract terminology, crossing the river can be considered a goal of reaching something, and the ability to walk can be considered a movement mechanic. All these concepts are available to describe the game in isolation, but what about game interactions? By game interactions, we refer to the actual gameplay and the moment-to-moment activity of playing the games. These activities all look so different, but actually they also have a lot of things in common. From an interaction perspective, for example, the first-person shooter here and Tetris have some things in common which might not be obvious from the surface. You can, for example, think about them both as involving some kind of steering. We can think of game interactions as the interaction work a given user performs with a game. The user plays the game through some input modality and receives the experience through the output modality. So what's needed here is a language that transcends beyond the specific input modality and beyond the game's representation. This is one of the complexities that games just have as mediums. To describe game interactions, we build upon the notion of tasks. Tasks represent a classic scientific concept in NCI, but we don't really talk much about them in games or as tools for game design. Tasks describe sequences of actions. They represent interaction work that people do. They have goals which explain why people do them, and you can think of them as being embedded into the experienced game world. If you are interested in the origins, read more in our full paper. We describe this situation using task hierarchies then. Task hierarchies are timelines that show how tasks, subtasks and actions unfold over time. Our contribution consists of basic task building blocks and a framework that demonstrate how to analyze and model gameplay as tasks. The basic building blocks are also known as core tasks in game scholarship. They are basic tasks that refines work on external assistance techniques initially defined. Our work refines and extends revised lists and animates them. You can think of core tasks as high-level categories that become starting points for classification. To unfold analysis further, we created a framework. It describes 4 tools which we demonstrate for 4 scientific application areas. With this, we can now create models of games gameplay. Identification classifies a specific segment of gameplay to a task. This goes beyond just mapping a game to a core task. Here on the left side is a simple game called Whack-A-Mole. We can describe the interactions in this game on different levels of abstraction. At the concrete level, we use representation language, while at the abstract level, this is where you find the basic task classification. The key is to identify the right design characteristic that describe this particular type of pointing. Sequencing relates to the frequency and duration of tasks, like looking at how melodies repeat in music. Composition refers to how the task is broken down into actions and operations. And the last tool, examination, refers to the process of discovering goals, feedback, and feed-forward opportunities. It should be clear that these models can help us synthesize previous work. But what can we use these tools for? How does it help game design? With the 4 tools in mind, I want to help us imagine what these tools will let us do. So first of all, it enables us to create conceptual models at our own chosen range of detail. At the most basic level, we can perform simple task classification with identification tool. If you want to go one step further from there, you can decompose it into a conceptual task hierarchy. If you want, you can also add more precise subclassification of your task. And at the most detailed level, we can create real-time models of the gameplay. The second use case is creating design landscapes, which you can use to navigate where to go with your gameplay design. Imagine that you create a map of games. Each dot on the map is a game grouped by similarity. For example, this over here could be a mini-golf game. We can now use our core task to draw the larger boundaries, and within those boundaries, we can start identifying subclassifications that might define new subcategories of core tasks. Which leads me to the next application, identifying design properties. Design properties are the things that make each game's implementation of its task unique. We exemplify design properties for pointing tasks in our paper. Finally, I also find the framework a nice provocative design tool that raises new questions in my game design process. What does Counter-Strike and Tetris have in common? What if racing games didn't use steering? When does aiming become pointing? So these are the key points. We can reduce complexity by considering games beyond their surface, and we can think of game interactions in terms of tasks. We can organize game interactions into some distinct categories. We can use this as a design tool to think interactions outside the box. We can use this for rigorous analysis, and it's designed to complement other frameworks and existing game ontology. We would like to thank all authors of previous work that made this framework possible. We want to thank the people who made great and freely available games. And we want to thank our students, our collaborators, our reviewers, and Susanne, Scott, and Mitchell for sharing their viewpoints on this subject. We created a website where you can explore the resources on the topic, including an animated video to explain the concepts and step-by-step guides. Our appendix aims to provide an overview of each core task, which you can use as a starting point for further research. Do feel free to get in touch with us on mail or social media if you have questions on this topic.